Okay, well, now that we've introduced the trig functions of right triangles, well, let's look at some application problems. It's important that you, of course, have the definitions down really well, because we're going to use those. The hardest part, I think, about these problems is really drawing a picture. If you get the picture right, I think you can do the problem. They're not that hard. But understanding what's going on is the hard part, I think. Alright, 24-foot ladder leaning against a tall building. The angle of elevation from the base of the ladder to the building is 40 degrees. That means the angle above the horizon. So 40 degrees, if you elevate that angle above the horizon, it goes up 40 degrees. So this angle here. Find how high the ladder reaches on the building. So they're asking you for this side of the triangle. Now, if they wanted this side, they would have to say how far is the base of the ladder from the building, something like that. Anyway, we would use sine, wouldn't we? Sine of 40 degrees is x over 24. So x equals 24 sine 40. And when you use your calculator, you should get about 15 feet, which makes sense, doesn't it? That sounds like about right. Alright, for this next one, a street in San Francisco has a 20% grade. That means for every, it rises 20 feet vertically for every horizontal distance of 100 feet. So the picture looks kind of like this. If this is your angle theta, they want you to find the angle of elevation of the street. Find a trig function that relates this angle with this side with this side. It would have to be tangent, wouldn't it? Tangent theta equals 20 over 100, which is 0.2. The way you answer the question, though, is using inverse trig functions. You would go like, we're going to talk more about this in much more depth later, but if tangent of theta is 0.2, then theta is inverse tangent of 0.2. And the way you get that is you get your calculator and enter second, and then enter inverse tangent, which is right here. Inverse tangent is right there. And then 0.2, hit enter, you should get about 11.3 degrees. That's what I get. Now before we do this next problem, let's talk about this right here. This says 28 degrees 40 minutes. There are 60 minutes per degree, so this is just another way to measure angles. There's 60 minutes per degree, so what you could do is take 40 minutes and convert it to decimal degrees. 40 minutes equals 40 minutes times 1 degree per 60 minutes. The minutes cancel and you get about 0.7 degrees. Similarly over here it says 7 degrees 30 minutes. Let's convert minutes to degrees. 30 minutes equals 30 minutes times 1 degree per 60 minutes, so when you divide it's not too surprising you get 1/2 of a degree. Okay, so anyway, for this particular problem here, what's going on is you're climbing up on this ladder right here and you're 100 feet from this building, and the angle of elevation to the top of the building, that's what we're calling theta, is 28 degrees 40 minutes. And the angle of depression, that's the angle below the horizontal to the bottom of the building, is 7 degrees 30 minutes. And you want to find the height of the building. This is a case where it might be nice to introduce other variables. Let's call this part A and this part B. So x equals A plus B, right? Anyway, so we converted theta to decimal degrees. It's 28.7 degrees. And we converted beta to decimal degrees at 7.5 degrees. So what we're going to do is look at each one of these separately. We're going to find a trig function that relates this angle with this side A, and you use tangent, of course. Tangent of 28.7 equals A over 100, so when you solve for A, you get 54.7 feet. Same is true for B. The tangent of 7.5, which is beta, equals B over 100. You solve for B, 100 times the tangent of 7.5, you get 13.2 feet. So x is just the sum of those two. So like I said, sometimes you have to introduce another variable. Okay, in this one, let's look at this picture here. You've got one ship that leaves and travels north, 13 knots, that means 13 nautical miles per hour. An hour later, a ship travels east at 15 nautical miles per hour, and then at 9 p.m., the first ship has been traveling 8 hours, as the second ship has been traveling for 7 hours. How far apart are they? Well, first of all, at 13 knots for 8 hours, ship A has gone 104 miles. Ship B, it's only been going 7 hours, but it's been going faster, so it's been going about the same distance. It's been going 105 miles. So in terms of how far apart they are, wouldn't you just use the Pythagorean theorem? If this distance is 104, this distance is 105 by the Pythagorean theorem, you get about 148. Now, the question is, what heading will this ship have to head at, have to go at to get to where this ship is? There's several ways of doing it. You would first find this angle theta. You could say the tangent of theta equals b over a, doesn't it? Which comes out to be just about 1. Let's just round it up to 1. Can you think of what angle has tangent 1? Wouldn't that be 45 degrees? But if you didn't know that, of course, you could use your calculator. You go second inverse tangent 1, enter, and you should get it right around, you should get 45 degrees. I did some rounding, but anyway. Now, how would you write that? There's two ways to go. You could say this is 45 degrees east of south. That's how we say this. When it's written like this, it's 45 degrees east of south. You see that? Another way to talk about this heading is if you just say it's a heading of 135 degrees, that's the angle that you drop down from the north, see? So if this angle is 45, this has to be 135, doesn't it? So if you just say 135 degrees, that means you're dropping down from the north 135 degrees. That's another way to write it. Let's look at this one. An airplane travels 165 miles per hour for 2 hours in a direction. Here we go. This is 62 degrees west of south. So here we go. And in the picture, if this is south right here, see? The 62 degrees west of south is this angle right here. How far south and how far west is the plane from Chicago? Okay, well, first of all, you know that the distance is 330 miles. That's the length of this line segment, right? 330 miles. So how would you find this y coordinate? This is how far south you are. You could say if this is 62, let's call this angle 28. That's probably what I would do, right? Call that angle 28. The sine of 28 is y over 330. You solve for y, you get 155. And then the way you find the horizontal distance x, you could say the cosine of 28 is x over 330. Solve for x, you get about 291 miles. Okay, let's do this last one here. This one's kind of hard. It depends on how you interpret it also. You might get two different answers. Jay and Sam are starting at the top of a hill, and they're 75 feet apart. I'm going to assume they're on the same side of the hill, okay? Because otherwise they wouldn't see each other. The angle of elevation for Jay is 22 degrees to the top of the hill, and the angle of elevation for Sam is 57 degrees to the top of the hill. So let's call this h is the height. This is what we're trying to find. So what I have to do is I'm introducing another variable x, and what we're going to do here, these are the hard ones. You're going to introduce a new variable x, and then I get two equations with two unknowns. Tangent of 57, isn't it h over x? So if you solve this for x, you get this. The tangent of 22, however, is h over this whole distance, which becomes 75 plus x. I cross multiply, and then I'm going to solve this for x also. You see, it's kind of a bit of work here. Tangent 22 is h over 75 plus x. You cross multiply this out, get all the terms that have, or get the term that has x by itself and divide by tangent 22. So I got two equations, I solved them both for x. Now I'm just going to set them equal to each other, see? And the way you finish this problem, it's kind of a lot of work. I'm going to solve this equation for h. It's kind of hard. You're going to cross multiply the right side out, get all the terms that have h on the left side, factor the h out, and divide by this mess. And when all the dust settles, you should have h is about 41 feet. Anyway, so those are kind of hard. We'll see you later. Bye-bye.